Okay, so we've talked about circumcenters. Circumcenters are where your three perpendicular bisectors touch. We've talked about incenters. That's where our three angle bisectors touch. Now we got to talk about medians and centroids. Okay, a median is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side of the triangle. So imagine a triangle. I put my pen or my pencil on one of the vertexes and I draw a line towards the opposite side of the triangle that goes through the midpoint of that side. That's a median. Okay? And a centroid is where your three medians touch. It's the point of concurrency of the three medians of a triangle that we also call the center of gravity. So I've got some here. Notice I start here at point Q and I go towards the opposite side and I go through the midpoint because these two pieces are the same, so QU is a median. RS is a median and PT is a median. Now what you need to know, so VP, the point of the median from the vertex to the centroid, is 2/3 of the way all the way through. So if PT is all the way through, PT is my median, then VP from the vertex to the centroid is 2/3 of that distance. So let's say I know PT is 24 and I want to figure out what PV is. Well, it's 2/3 of 24, which is 16. So this piece would be 16 and this piece is always twice as big as this piece because this is 2/3, that's 1/3. So if that's 16, that has to be 8. 16 plus 8 would give me the full 24. Lots of examples in class, but just know that this is what needs to happen when I'm talking about centroids. And an example, again, I glossed over this section. I don't know why y'all's is a little different. The centroid is always inside the triangle. It is called the center of gravity because it is the point of balance. It's where the triangle will balance. You've got 4 examples here. I only have 2. See if you can get all 4 of yours. So it wants to know how long AG is, but we know how long AF is. AF is all the way through, and we're told that it's 9 units, all the way across. But AG, remember, is 2/3 of that. So AG is 2/3 of AF. And so if AF is 9, then 2/3 of 9, 2 times 9 is 18. 18 divided by 3 is 6. So AG would be 6. And half of 6 would be 3, so GF, so 6 plus 3 does equal to 9 all the way across. And CE, so we want to know how long CE is, but we know how long GE is. GE is 2.4. Remember, but this is 2/3 of the way. This is only 1/3. So this distance from G to E is half the distance from G to C. So if this is GE, 2.4, then GC must be 2 times as big, or 4.8. So now I know that GE is 2.4 and GC is 4.8. So to get CE all the way across, 2.4 plus 4.8, 7.2. Okay, that is medians and centroids. One more type of triangle center, and this deals with altitudes and orthocenters. The altitude of a triangle. It is the perpendicular segment from a vertex to the line containing the opposite side. So I start at the vertex of a triangle, I go towards the opposite side of the triangle, and it's perpendicular to the line containing the opposite side of the triangle. And the orthocenter is the point of concurrency of the 3 altitudes of the triangle. So it's where the 3 altitudes touch. That's called the orthocenter of the triangle. So it gives us some examples. If there's an acute triangle, start from that vertex, perpendicular line, that would make that my altitude, sorry. Just kind of spaced out there. Altitude. If I go here, go from this vertex, draw my altitude perpendicular to the opposite side. And if it's a right triangle, my altitudes are already there. If I start at this vertex and I go perpendicular to this side, that's an altitude, and this is also an altitude. So there's a picture, some examples. My altitude's here. Orthocenter of an acute is inside the triangle. orthocenter of an obtuse outside the triangle. We'll talk about right triangles in class. Okay, whole lot of algebra going on over here. It's a good question. It's a good problem. It tells us to find the orthocenter of triangle JKL with vertices J negative 4, 2, so there's J, K negative 2, 6, and L 2, 2. So I drew in the triangle, and it wants to know where the orthocenter is. So it wants to know where the three altitudes touch. Well, because I have a horizontal line here, it's really easy to get the altitude KL. This one right here. Because I go straight from K, I go straight down. That means it's perpendicular to JL. So I already have one of my altitudes. It's right there. And I know the equation of that line, or we should. If a line's going straight up and down, it's always x equals whatever it crosses the x-axis. So this line is x equals negative 2. So I know one of my altitudes. I want to find the other one. And the one that I'm choosing to go for is the one that goes from J this direction. So I'll show you where this line comes from here in a little bit. But what's an altitude again? It's a line that goes from a vertex of the triangle and it's perpendicular to the opposite side of the triangle. So what must the slope be? Well, can't I figure out the slope of KL? And then the perpendicular slope must be the negative reciprocal like we've been doing in class. So let's do that. So let's find the slope of KL. y2 minus y1 over x2 minus x1 gives me 2 minus 6 over 2 minus negative 2, which gives me negative 4 over 4, or negative 1. So that's the slope of KL. Slope of KL is negative 1. So then what must be the slope of a line perpendicular to that if this slope is negative 1? By now I'm hoping that we know it's positive 1. So I know that the slope of the perpendicular line to KL is positive 1. Now to use my y equals mx plus b like we did with circumcenters, I need to know a point that my line goes through. But remember, if it's an altitude, it must go through one of the vertices of the triangle. So again, I told you I'm trying to get this altitude. So what point do I know that it goes through? It must go through J. And I know the coordinates of J are negative 4, 2. So that's the x and that's the y that I'm going to use. And then I just plug in. So I use y equals mx plus b. The y that I'm going to use is the 2 from point J. The m I already got. The x, I'm going from point J, negative 4, plug in. Add 4 to both sides, and I get that b is equal to 6. So this is the equation of another altitude. But up here, it wanted to know the location. So if I just look at the graph, I can see where they touch. They touch at negative 2, 4. But if I didn't have the graph and I wanted to know what I could do, I already know what the x is. So I can plug in the negative 2 here for x into this x, which gives me y equals x plus 6. Plug in the negative 2 for the x. Y equals negative 2 plus 6, so y is equal to 4. And so my answer is negative 2, 4, which is what I have right there. Again, lots of examples to follow in class. One more thing we gotta hit, and it's called midsegments. Okay, the midsegment of a triangle. It's a segment that joins the midpoints of two sides of the triangle. So imagine I have a triangle. I mark the midpoints of two sides of the triangle, and then I connect them with a segment. That's called a midsegment. How many can I have in one triangle? It's 3. So now let's do some experimenting. Okay, so it tells me in the graph point K. It tells me to point K, midpoint of HG. Says find in graph point L, which is the midpoint of HJ. So I did that. So I did a little bit of work. I did some rise over run and just, how much do I go up, how much do I go down to get from G to H. Did some midpoint formula, and I found that K, the midpoint of HG, is at negative 6, 2. So I'll put a little mark. It says do that with point L in the midpoint of HJ, and I found the midpoint of HJ to be negative 2, 4. So there's L, and then I connected them with segment KL. It says find the length of KL. Remember 2 letters, capital, side by side? Nothing on top means distance. So how long is KL? So all I did was use the distance formula, which means you subtract your x's squared plus subtract your y's squared. Simplify this. We haven't talked about simplified radical form yet. We'll get to it. All I did was simplify that, and I got that this equals the square root of 20. Square root of 20 I can rewrite as 4 times 5. 4 times 5 is 20. The square root of 4 is 2, and the root 5 I'm leaving alone because there is no square root of 5. So KL I'm saying is 2 square root of 5. Do the same thing for the length of GJ. Put it into the distance formula, subtract the x's and square, plus subtract the y's and squared, simplify that, and I get square root of 80. Well, I know that I can rewrite 80 as 16 times 5. So the square root of square root of 16 is just 4, and that 5 that stays in the box, so it's 4 root 5. So I notice what's true about GJ and KL. GJ is 2 times as big as KL. That's what I notice. GJ is 2 times the length of KL. And if I look at their slopes, if I do rise over run for KL, I notice that I go up 2 and over 4 for KL, rise over run, which is just 1 over 2. And if I look at the slope of GJ, I go up 4 and over 8, rise over run, which simplifies to 1 over 2. And if the slopes are the same, what's true about the lines? They are parallel. So these two things we combine right here into the triangle midsegment theorem. A midsegment of a triangle is parallel to a side of the triangle, and its length is half the length of that side. So that's important. That'll help us answer some questions. So I come over here and I look at these questions. It says, given that ST, so here's ST, is 7.4, find each measure. So here's ST 7.4. It wants to know what UW is. But UW, because of the markings, tells us that it's a midsegment. If it's a midsegment, it must be half of this side. So if this is 7.4, half of 7.4 is 3.7. So I know that UW must be 3.7. Okay, find the measure of angle SVU. So SVU, well, I know this is a midsegment, which means these two lines are parallel. I know this is a midsegment, so this and this must be parallel. Well, that opens up some routes for us to take. Alternate interior angles, same side interior angles, different ways we could approach this. Well, this is 41. These are same side interiors, so that's got to be 139. These make a linear pair, so SVU must be 41 degrees. RT, how far is it from R all the way to T? Well, I know UV is 5.2. So RT must be 2 times as big, which must be 10.4. And over here, okay, I've got some midsegments. This is a midsegment, so this piece must be half as big as this piece, or I can do 2 of these equals this. So I'm doing 2 times 2x minus 3, so 2 of these must be equal to this, equals 5x minus 12. Do a little algebra and I get that x is equal to 6. It wants to know what y is equal to, but again, if this is a midsegment, these two segments are parallel to each other. So I'll call this a transversal, so 117 and y must be same side interior angles. So I can do 180 minus 117 gives me 63 degrees, so y equals 63 degrees.